Hello and welcome to this video on the Hansadrone Precision Approach Service. In this video we will show how to use the service to fly a drone in a simulator, so no real drone is needed. If you haven't already, please watch our Getting Started video first on how to obtain an API key and how to set up the Hansadrone service. We will learn how to set up the simulator, connect it to the MAVSDK and how to connect the MAVSDK via a Python script to the Hansadrone backend. We will also do a quick walkthrough on the Python script to see how the components work together. First, if you don't have it already, we need to install Python. You can download it from python.org. Next, we install the MAVSDK for Python. This is done by using the Python package installer PI. Now we install a drone simulator. In this example, we will use a simple and lightweight simulator called jmavsim. But other simulators like Gazebo will work as well. jmavsim runs the full PX4 autopilot stack in a simulated environment. You can download jmavsim from the project website and follow the instructions provided there. And of course, we need to install the Hansadrone app on our smartphone as described in the Getting Started video. Before we start jmavsim, we need to tell the simulator where it is actually located. Else our drone might fly around half the globe as we define a corridor with local coordinates with the app. So set latitude, longitude and altitude values close to your actual location. The distance to your location should be within the range value that we set later in the Python script. When all is set, we can start the simulator. This will take a while. In the meantime, we take a look at the last component, which is the Hansadrone Python script. This script connects the cloud backend to the MAVSDK. You can download it from the Hansadrone GitHub repository. Link is on our website. In the script, we need to enter the same API key that we have already entered to our mobile app as well. Let's do a quick walkthrough to understand what the script does. First, we set a couple of parameters to control our drone flight. One of them is the range value, which sets the maximum radius between the drone takeoff location that we have just defined in jmavsim and our own location where the drone will fly to. Feel free to adjust the other parameters according to your needs. Next, the script connects to the drone simulator using UDP port 14540. Make sure all other connections are commented out. Let's start the script meanwhile as we walk through further. Once we have a connection established, the script is setting a couple of fail-safe parameters and then connects to the cloud to set the drone status to connected. The script will wait 60 seconds for the app to be in connected state as well, and then set the drone status to available. This will trigger the UI flow for the corridor definition on the smartphone. Again, the script waits for a minute to allow the customer to define a suitable free corridor. Defining a corridor is done by pointing the smartphone in a direction where there is clear view of the sky. The rectangle on the screen will turn green once the integrated AI has recognized free sky. Then simply press the button to define that corridor. When done, the script loads the fixed point coordinates and the corridor data and performs a range check. If all is fine, the drone is ready to arm and take off. The drone will take off in jmavsim to the specified cruising altitude, rotate, and fly to the defined fixed point. When it has arrived, it will rotate towards the customer and start sending out light signals. As we don't have a real drone, we need to simulate this by using a red LED. The LED can be pointed anywhere within the corridor frame in the beginning, as the Hansadrone service tolerates large deviations. Towards the end of the approach, we should of course hold the LED near the center of the corridor to simulate the corrected drone position. The script will wait a minute for the drone to be recognized and then load the deviations from the backend. These deviations represent the difference of the actual drone position from the center of the defined corridor in degrees. They are used to calculate the correction values needed for the first approach step. The drone switches now to off-board mode to approach the customer inside the safe corridor. This process will be repeated a couple of times until the drone has reached the customer's location. Calculation of the corrected parameters is actually the tricky part, because we don't know where the deviations come from. It can be the compass direction is off by a couple of degrees, or it can be some offset in the GPS coordinates of the smartphone or the drone, or it can be both at the same time. So we are calculating interpolated corrections at each step. While the drone position usually is known with good accuracy, the smartphone position and compass heading can be off by considerable values. Eventually, the drone has reached the customer's location. It will end up exactly in front of the smartphone camera with a tolerance of just a few tenths of centimeters. It will hover there a couple of seconds and then initiate the flight back. As we don't have any ultrasound sensors in our simulator, we leave this part in the script commented out and rather stop the drone at a safe height above ground. In the remaining part of the script, the drone will fly back to the fixed point and then home to its takeoff location all by itself. And of course, you can monitor all the data that is being exchanged between the smartphone and the Python script on the cockpit dashboard under hansadrone.com/cockpit. So that's it for today. Please also check out our video on how to use the service and the MAVSDK script to fly a real drone. Hansadrone is in MVP mode as of now, so any feedback and comments are much appreciated. Just drop us a mail at contact@hansadrone.com or leave a comment under this video. Thanks for watching and fly safe.